Let's now discuss how to find the argument in the third quadrant. Again, the argument, or theta, is the smallest angle from the positive real axis to the vector of the modulus. So previously, we were moving counterclockwise to get to the vector of the modulus, but in this case, it would always require us to go beyond 180 degrees, which means moving counterclockwise from the real axis is not the way we want to go when we are finding the argument in the third quadrant. Instead, we want to move clockwise to get to the vector of the modulus. That will now be our theta, or argument. When we do so, we'll wind up creating a right triangle by drawing a dotted line up to the real axis as we normally do. And that creates an angle closest to the origin. So we'll use our alpha angle again. So we'll calculate the alpha angle and subtract it from 180 degrees to find our argument, just as we did previously in quadrant 2. Except one difference is the argument will be negative since the smallest angle to the vector of the modulus is found by moving clockwise. Previously, we were moving counterclockwise and all of our angles were positive. Since we're moving in the opposite direction now, which is clockwise, the angles will now be negative. So the range of values will be from 0 to positive 180 degrees, or from 0 to negative 180 degrees for all arguments. And again here, we will calculate negative theta by subtracting alpha from 180 degrees. So we'll do 180 minus alpha, but we'll still need to multiply the value that we get times negative 1 in order to get theta, because all of our angles now in quadrant 3 must be negative. So let's take a look at an example. If the alpha angle were 30 degrees, then the argument is going to wind up being negative 150 degrees. If the alpha angle comes out to be 20 degrees, then the argument, or theta, will wind up being negative 160 degrees. So the net total will be 180, but the theta angle, or the argument, must be negative. So let's say we were asked to find the argument of negative 4 minus 3i. We're going to draw our right triangle. So step 1, go to negative 4 on the real axis. Step 2, draw a dotted line down to negative 3 on the imaginary axis, and then plot the point. The fourth step, draw a line from the point to the origin. The angle closest to the origin is our alpha angle. So the side adjacent to the alpha angle has a length of 4, the real number. And the side opposite of alpha is 3, the net value of the imaginary number. And if this is our alpha, then from here to the positive real axis is our argument, or theta. So we'll first find the inverse tangent of the alpha angle. So you'll want to do the opposite side over the adjacent. So you find the inverse tangent of 3 over 4 with the calculator in degrees mode, and that lets you know that the alpha angle is equal to 37 degrees. Subtract that from 180 degrees, and 180 minus 37 degrees gives us 143 degrees. This is negative theta. You want to multiply negative theta by negative 1 because our argument is going to be negative in quadrant 3. When we multiply 143 degrees times negative 1, we get that theta, or the argument, is equal to negative 143 degrees. And in radian form, multiply it by pi over 180 degrees. So negative 143 degrees divided by 180 degrees gives you an argument equal to negative 0.79 radian. So that is how you go about finding the argument in quadrant 3. Let's now have you try a few practice questions. Question number 1. Find the argument of negative 2 minus 5i. Question number 2. find the argument of negative 3 minus 10i. In question number 3, find the argument of negative 7 minus 2i. Pause the video, answer these questions, and then press play when you are ready to begin. Question number 1, we want to find the argument of negative 2 minus 5i. So step 1, go to negative 2 on the real axis. Step 2, draw a dotted line down to negative 5 on the imaginary axis. And step 3, plot the point. Step 4, draw a line from the point to the origin, creating our right triangle. And the alpha angle is closest to the origin here. So our right triangle has an alpha angle with an adjacent side equal to 2 and an opposite side equal to 5. And if this is our alpha, then this is our argument, or theta. So to find alpha, you'll want to find the inverse tangent of 5 over 2, opposite over adjacent. So that lets us know that the alpha angle is equal to the inverse tangent of 5 over 2, which is equal to 68 degrees. So when we subtract the alpha angle from 180 degrees, we get the negative theta angle is equal to 112 degrees. We then want to multiply negative theta by negative 1. So 112 degrees times negative 1 shows us that the argument, or theta, is equal to negative 112 degrees. And now if we want this in radian form, we'll multiply it by pi over 180 degrees. Negative 112 divided by 180 degrees will give you theta is equal to negative 0.62 radian. So the answer is negative 112 degrees, or negative 0.62 radian. Question number 2. You are asked to find the argument of negative 3 minus 10i. Step 1, go to negative 3 on the real axis. Step 2, draw a dotted line down to negative 10 on the imaginary axis, and then plot the point. The fourth step, you then draw a line from the point to the origin to create a right triangle. And now the angle closest to the origin is going to be our alpha angle. So our right triangle has an adjacent side to alpha that is equal to 3, and a side opposite of the alpha angle with a length of 10. And if this is our alpha angle, then from this vector to the positive real axis is our theta, or argument. So we'll use the inverse tangent of the opposite side over the adjacent side to find alpha, and then subtract that from 180 degrees. So the inverse tangent of 10 over 3 shows us that the alpha angle is equal to 73 degrees. Subtract that from 180 degrees, and we see that the negative theta is equal to 107 degrees. And if we multiply negative theta by negative 1, we get 107 degrees times negative 1, which means our theta, or argument, is equal to negative 107 degrees. And now we'll want to multiply the answer by pi over 180 degrees. 107 divided by 180 shows us that theta is equal to negative 0.59 radian. So the answer to question number 2 is negative 107 degrees, or negative 0.59 radian. In question number 3, we're asked to find the argument of negative 7 minus 2i. So step 1, go to negative 7 on the real axis. And step 2, draw a dotted line down to negative 2 on the imaginary axis, and then plot the point. Draw a line from the point to the origin, creating our right triangle in quadrant 3, and closest to the origin as our angle alpha, giving us a right triangle with an adjacent side to alpha with a length of 7, and a side opposite of alpha equivalent to 2. So now we have our alpha angle and our argument. So we'll use the inverse tangent of the opposite side 2 divided by the adjacent side 7 to find our alpha angle. And then we'll subtract that from 180 degrees to get our negative theta. So the inverse tangent of 2 over 7 shows that the alpha angle is equal to 16 degrees. Subtract the alpha angle from 180 degrees. And that shows us that negative theta is equal to 164 degrees. We then want to multiply negative theta by negative 1 to get theta. So theta is equal to 164 degrees times negative 1, which lets us know that theta, or the argument, is equal to negative 164 degrees. And if we would like this answer in radian form, we want to multiply it by pi over 180 degrees. Negative 164 divided by 180 degrees shows that theta, or the argument, is also equal to negative 0.91 radian. So the answer is negative 164 degrees, or negative 0.91 radian.